Okay, and we're back. All right. Now, when you solve a trigonometric equation, this is what I said, there's curveballs that show up here. When you solve a trigonometric equation that has a coefficient of x, okay, this kind of, there's a lot of different ways to talk about this, and they're all just like in one big rat's nest in my head. And I want to try to streamline it, okay? When you look at your two solutions, now typically, as I said in the video prior to the one prior to this, I said we look at a range that's between 0 and 2 pi, right? Okay. Now, if you look at these two outputs, pi over 12 and 7 pi over 12, these are the solutions that if I put them here and I double them, I get a tangent value of radical 3 over 3. Now stay with me here because this gets a little strange. If you can follow me through this grade, at the end I'll just tell you like this is what you need to do. Okay? But I want to show you the why and the how. Pi over 12 is like right here. Right? It's half of pi over 6, so it's a 15-degree angle. 7 pi over 12 is just barely past pi over 2. It's 15 degrees past pi over 2, which is like up here. Okay? So, am I saying that all of the angles that are solutions to this problem are found before we even make half of the rotation through 2 pi? There's got to be more solutions in there. Okay? And there are. Okay? The idea here is when we get these values, come back to this step and add 2 pi from here. What's 2 pi in terms of 6? 12 pi over 6. So if we add 13 pi, if we add 12 pi over 6 to this, I get 13 pi over 6. And if I divide 13 pi over 6 by 2, I get 13 pi over 12. That's a solution. So I'm adding the 2 pi like we did, like we're doing here. I'm doing one of those as a part of my solution set rather than just making it generic like this. Okay? So I'm adding the 2 pi here. I'm going to add 2 pi to this value as well and get 19 pi over 6 because 7 pi over 6 plus 12 pi over 6 is 19 pi over 6. And when I divide that by 2, I get 19 pi over 12. All of these answers are less than 2 pi. Okay? So instead of making our solution generic with this, we're actually finding those next two solutions. Okay? Now, if you wanted to keep going, okay, I'm going to do this, I'm going to color code this now. Here's pi over 6. 13 pi over 6 is coterminal with pi over 6. It's in the same spot. We got it by adding 2 pi. What would be the next coterminal angle with 13 pi over 6? That would be 25 pi over 6. Now, if I write that and then I divide it by 2, that would be 25 pi over 12, which goes beyond that acceptable range that they're giving us. So this, when you see a problem with a double angle, you're probably going to get constrained to a range between 0 and 2 pi, and you just keep finding coterminal angles until you've exceeded that range, and then you stop with your solutions. So we get these 4 values as our answers, right? Even though the arctangent only produced 2, we find 2 coterminal angles for these and include them in our solution. All right? like I said, it's a curveball, it's a little bit of a quirk when we see that double angle.